Hello guys, my name is Vijay and welcome back to my channel. This is a second video in this Spark series, and in the previous one we talked about big data evolution and how companies like Google and Yahoo solved their big data challenges. In order to solve their big data problem, they created two things. One is a distributed file system where large data can be divided into smaller chunks and can be distributed across cluster of machines. And another was a programming model like MapReduce to parallelly process those distributed data. Okay, so in this particular video, we are going to see what actually big data is. You still might be having some confusion, so let's discuss it. So big data refers to extremely large and complex data set that are difficult to manage, process, and analyze using traditional data processing systems. So system like RDBMS, ERP system, and SQL servers were not powerful enough to process massive amount of data. Correct? Because let's say if you have small files in your own laptop, let's say it is of 10 GB, then it can be easily processed with the amount of RAM that you have. But if you have suppose 10 terabyte of data, then first it will not be accommodated in a single laptop or machine. Okay, and also we cannot install enough RAM to single system to process it because of hardware limitations. Correct? That is where our need started to have a cluster of machines to store large data in smaller chunks, and also a processing mechanism to process those parallelly. Okay, so big data typically have three defining characteristics known as three V's of big data. So let's discuss this one by one. First one is volume. So big data involves massive amount of data, and sometimes it surpasses the capabilities of traditional systems in terms of scale, because big data can range from terabyte to petabytes and even exabyte of data. And nowadays we cannot even imagine how much data we are generating. It is way more than we can think of. Okay, then another one we have is velocity. So big data is generated and needs to be processed at high speed, and with the rise of real-time data sources such as social media, sensor data, and transaction logs, there is a need to capture, process, and analyze data in a near real time or even real time. So if the data is generated faster, then that needs to be processed faster as well. Correct? Otherwise there will not be any relevance to that data if we are processing, if we are not processing it in a timely manner. Correct? Then we have a variety, means big data comes in various format and structures. It includes structured data like uh, data in a table format that we have in a relational database system, semi-structured data like we have XML and JSON files, and unstructured data like some text document, images, and volume. So big data can have diverse data types and sources, making it challenging to process and analyze using traditional system, because back in days we were mostly dealing with structured data, but now in this digital era we have different structure and format of data coming from all over the place. Okay, so in a nutshell, traditional systems were designed for handling a smaller and structured data set and were not built to handle the complexities and scale of big data. So let's see some of the reasons why traditional systems fall short in solving big data problems. So first one is scalability. Traditional systems often operates on a single machine or a limited number of machines, which cannot be effectively handle enormous volume of data in big data scenarios, and scaling up traditional systems to handle big data requires significant hardware improvement. Correct? And architectural changes. Okay, then another one is processing speed. So traditional systems are optimized for processing small to medium sized data set, and processing large scale data effectively requires parallel processing across multiple machines. Correct? And traditional system lack this distributed computing capabilities. Correct? Then we have another one, that is storage and management. So big data often exceeds the storage capacity of traditional system, as we have already talked about, and traditional databases may not provide the necessary scalability and flexibility to handle diverse data types and formats. So traditional data management practices may not be suitable for big data, and it leads to challenges in storage, organization, and retrieval. Then another one we have is analytical capabilities. So traditional systems are typically optimized for structured data analysis and may struggle to handle unstructured and semi-structured data type, because big data often requires advanced analytics techniques such as machine learning, text mining, and graph analysis, which traditional system may lack. Okay. So, to address these limitations, new technologies and frameworks have emerged, such as MapReduce, Apache Hadoop, Apache Spark, and these tools and platforms provide scalable, distributed, and parallel processing capabilities to effectively handle big data and enable advanced analytics at scale. So you would have got an idea what big data is and what challenges traditional system faced, correct? So that is what I wanted to discuss in this video. And if you found this video insightful, do like and share, and we'll continue this series. So for time being, stay connected and keep learning. Goodbye.